Okay, next question, 6.4. I think this is the first time we are doing horizontal bar chart, but it is essentially more or less the same as the vertical bar chart. So we want to derive the mean log real earnings over gender and over race. Okay, graphics, bar chart, mean log earnings over, let's go back to the question, over gender, over race. Just want to double check there's nothing here, but here you rather take horizontal bar chart. Okay, so same old story. On average, the white male individuals earn the highest in log terms. Okay. Next one, histogram. If we go through the question indicates we only want to include people aged at least 10 years old. The width of each interval is 10 years, and we only want to look at people living in Western Cape. And then age is a discrete variable. So let's do this histogram graphics. Histogram. Discrete variable, age, width of the bin 5, 10 years old, y-axis percent, but I better impose the restriction clearly. If age is at least 10 years old and province equals 1, the question indicates only include people living in Western Cape. Density plot, okay. Just check the by area, there's nothing over there, okay. Okay. It doesn't look like a normal distribution, clearly. Okay. Next one, log real earnings, which is a continuous variable because it involves decimal and only starting from 4 Rand in log terms. In Gauteng only. Okay, I actually want to check what is the minimum value of log earnings. Okay, let's do a summary stats. Okay, about 4 actually, the minimum value. So graphics, histogram, continuous variable, log earnings 1, y-axis show percentage distribution. The width of the bin is, let's go back to the question, it is 1 actually. 1. Lower limit is 4. If restriction, I will play it safe. Log earnings 1 is at least equal to 4. And then province equals 7. Because the question indicates that only people from Gauteng will be included. Okay. Density plot. Okay, that is still on. That is still fine. Okay. Okay. And then we actually finished question 6. So we have learned quite a lot of graphical sketch skills. We have plotted. Let's do a revision. I mean a summary. Box plot. XY scatter plot. Pie chart. Remember the by option works well for the pie chart. Horizontal bar, vertical bar chart. Histogram. And horizontal bar chart. Okay. Then we can move on to the next question. So we don't really need to save the data unless you really want to then save it as a different name. By the way, how can we save a starter file? If you want to save it without changing the name, then you click this option save. Then it just replaces the older version. So it is still named as number 3. But if you want to save it as another name, then file, save as. Then I assume you know what to do. But let's clear this data file and then let's open starter file number 4. Okay, we want to run regressions, OLS, and probe it. Okay, so let's go through the data set. Let's do a summary stats. I want to know the sample size. Okay, it is the 2007 community survey, unofficially known as mini census. And this time I include the full data set, all the observations. Indeed, 243,000 households took part. So let's go through the variables. This is household income, household size. I think everyone knows what they stand for. a dummy variable indicating whether the household head is employed or not. So let's do a tabulation. It must be binary, either 1 or 0. So 1 stands for employed, 0 means not employed. Years of education, and then years of education category, can I tap the educate? No schooling, incomplete primary, incomplete secondary, matric, post-matric certificate, diploma, and degree. Age, let's do a summary stats on age. Okay, as young as 5 years old, and then someone is 118 years old. Gender, race, province, we know what it is. And then the unique household number, let's look at that. Okay, so you can see each household was given a unique household number. Okay. And then let's go to the main question, 7.1.1. I think it is easy. Per capita income is equal to household income divided by household size. So generate, I call it PERC, per capita. Y stands for income. So per capita income equals household income divided by household size. Okay. Okay, that should be fine, but this is in nominal terms, and then we want to have 2016 December as the base year or the base month. So, but remember the community survey took place in 2007, so we want to convert the prices or the income value into 2016 December prices, and the CPI is given to you 54.9, so let's derive real per capita income. So generate, let me call it real PERC, so real per capita income equals the nominal per capita income divided by CPI, which is 54.9 times 100. Okay. Okay, you see the two variables there. You can give a description using the label variable command, but that's not the focus of this question. So I'm going to skip that. And then I need to run the regressions now. Okay. And then my Y variable is log real per capita income. So I must still generate log real per capita income. Generate log real per C is equal to the log of real per capita income. Can I just go back to the question? Yeah, indeed, it should be named as log real per C because I want to be consistent, sticking with what I did at that time. Okay. Okay, happy with that? And now I need to run the regressions. So I need to include province. In other words, I need to create the province dummies. So I think Western Cape is the reference group. I need to generate the race dummies, gender dummies, age. I would generate dummies as follows. Those who are aged between 15 to 24, 25 to 34, and so forth. So 10-year interval. Education, I need to generate dummies. Primary, secondary, and so forth. So the reference group is no schooling. Household size, it is fine. It is already a continuous variable. It is not a dummy variable. Okay, so leave it as it is. And then the employment dummy is already generated. It is already available in the dataset. So let's keep these in mind. Let me highlight these variables. So let's create the province dummy. And this is the quick way to generate dummy variables. So tab province, generate province. And then you are going to see 9 provincial dummies automatically created by Stata. Okay. Do you see the 9 dummies? Province 1 and so forth up to province 9. But I don't think if you share the data set with someone else, maybe your friends or your colleagues may not understand what province 1 stands for. So it is better to rename the 9 dummies so that everyone would be on the same page. So we are using the old skill we learned from yesterday. Rename the first dummy as Western Cape dummy. Second one, Eastern Cape. Next one, Northern Cape. And I think you should be fine for the rest. KwaZulu-Natal, Northwest, Gauteng, Mpumalanga, and Limpopo. Okay. So I'm done with province. Okay. Next one is the race dummy. I think if you understand how I created the provincial dummies, you should have no problems with the racial and gender dummy. So the next one, tab race, generate race. Then do you see the 4 racial dummies? Then the next one is the same old story, just rename it. Rename each dummy. Okay. Then the next one is gender. Okay. Then again, rename each dummy. Obviously, we call the first one male dummy. The next one, it makes sense to call it female dummy. Okay. Sorted with these one. Let's do the education one, which is more straightforward. So we use the educate one. Generate educate. So there will be 6 educate dummies. Okay, 6. I need to remember how I rename the variables: prime, secondary, matric, cert, dip, and degree. So the first one, I will call this none. Those who never went to school, that will be the reference group or reference category. The next one, prime. Next one is secondary, matric. I call this one cert dip. I know it sounds a bit weird, okay. And then the last one is degree. Okay, now the tricky one is the age cohort dummy, because remember, age is really not a categorical variable. It is a discrete numerical variable. So it would take a bit of time to generate the age cohort dummy. So let's go back to this one. So the reference category would be age 0 to 14 years old. Then we have 15 to 24 and so forth, and then over 64. Okay, so let's generate. Okay, first one. Let me call it age 0 to 14. First of all, I assume this dummy equals 0 for everyone. And then I replace. This dummy would be given a value of 1, providing certain condition is met. So I need to include the if restriction. If the person is really aged between 0 and 14, then please, this age 0, you see I almost made a typo error. Replace age 0 to 14 equals 1. Okay. Then the next one, age 15 to 24. First of all, assume it is equal to 0 to everyone, and then replace this is equal to 1 if the person is really aged 15 to 24. Okay. Then I think you should be fine with the next few. So I'm not going to talk now. I will just type the command. Oopsie, I almost made a typo error. Okay. 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 I think the last one we need to be careful. Those who are over 65 years old, over 64. Replace this dummy equals 1 if age is at least 65.